Hello class, good day. Welcome to our subject, Theory of Structures or Structural Theory. And mahababang bakasyon. I hope you are all well. Today I'll be discussing now the moment distribution method for our practice problem. Let's look on this example. Where to determine the internal moments at each support of the beam shown, wherein EI is constant. Since this point A and point D are fixed supports, and we have call this joints on B and C, we have an indeterminate structure. Thus, we will apply the moment distribution method. So again, class, you know me already that we have to approach procedurally. So systematically, we have the following steps. Where to identify the stiffness and distribution factors based on our constants or what has already been discussed in the lectures and the books. You are to identify the fixed end moments, set up the table, carry over the factors, summarize the columns, and calculate for the reactions or solve for the unknowns, because sometimes the problem will require you to draw the shear and bending moment diagram. So we will just recall our methods on statics of rigid bodies and mechanics of materials. Okay, so essentially this is basically it. Our approach for the moment distribution method. So we're to identify the stiffness factors. For the following, we have the formula 4EI over L. Okay, so I hope you remember that formula, that 4EI over the length of the segment. Okay, in this case, segment AB with the length 12, segment BC with the length 12 also, and segment CD with the length of 8. That's why 4EI over 8. Now, how can you solve for the distribution factors? Depending on the rotatability of the supports or the joints. So in this case, we have a fixed support of A, since this is give you an infinite value, meaning 4 over uh, infinite, 4EI over infinite will give us 0. Okay, so that will be DFAB and DFBC will have 0 because of the fixed supports at the end. Now, how about DF or the distribution factors? Take note kasi this is distribution factors, not degree of freedom. Okay? So that will be DFBA, DFBC will have the same value of 0.5. Why? Because we have the constant for EI over the length, 12, and for BC, 12 also. Okay? Let me use the laser. Okay? 12 also. Now, how about in this case, DFCB? Since we have now a different, we have now a loading, okay, so that will be DFCB will be connected to DFCD. Now that will be 4EI over 12, and then plus over the length of CB, and then the DFCD, 4EI over 8, okay. Now for DFCD, that will be this one. Now in this one, that will be 4EI over 8 over 4EI over 12, the length of CB, and then the length of CD. So always take note, class, that every joint will must give you a distribution factor summary of 1. If you sum 0.4 plus 0.6, that will be 1. Okay? So take note of that. There's two different loads. Okay? If you will have any question, comment down in this video or message me in my Facebook or in my email address. Thank you, class. Now, we are to identify the fixed end moments. Oh, by the way, where are the formulas? Okay, pause. Let's pause the video. Wait a minute, guys. Sorry about that. I forgot to copy the... Okay, so in this case, we are now to identify the fixed end moment of the following segments, A, B, B, C, and C, D. Now, question. Why does we do not have any fixed end moment at A, B? In this case, because you don't have any load, alright? You don't have any load for the segment AB. So let's look on FEMBC. That will be a distributed load all over. So this case, no? Omega L squared over 12. So correct. We have here omega L squared over 12. BC giving us omega L squared over 12. Negative because of clockwise direction. Alright? Now how about FEMCB in this case, this segment? Meaning you'll just have the opposite, counterclockwise for CB. Alright? This one. Right? Okay. Now next. Um, a key factor here, class, that you need to identify is BC. Why is it clockwise? So as you can see here, omega L squared over 12, you are parang we mirrored this. We mirrored this, right? So the first letter will give you the clockwise direction. Okay? So as in this case, this will be so FMCB will give us the opposite. Okay? Positive 240 kilonewton meter. Okay? Now, FEMCD, what will be this one? You have a single load at 250 kilonewton at the middle. Alright? So that will be this one. That will be PL over 8. Okay? So for FEMCD is different from FEMDC. We'll get first the FEMCD, that will be this one. Getting the mirror again. So that will give us FEMCD negative PL over 8. This one. Okay? Clockwise. And the other one will give us FEMDC, the other end PL over 8. Positive. Okay? That will be our fixed end moments. So now, how do we know the table? So by filling up this table, we can easily solve for the problem. But let's focus first on row 1, wherein we identified the joints A, B, C, and D. Okay, what are these? So, and why is it arranged that way? So, take note of this because it is this line. Okay, it is this beam A, B, C, B, C, and then C, D. Okay, and then we have characterized per joint the following. You have segment AB and BA. You have segment BC and CB. You have segment CD and then segment DC. Okay, for this one, and for this one. Alright? Now, as you have identified already the distribution factors, so we can easily input the following. We have AB and DC to be 0 because it is on fixed supports. Alright? And then for BA and BC, 0.5, 0.5, and then CB and CD, 0.4 and 0.6. What is our sum supposed to be? It always should be equal to 1. Okay? Now, ito na. Let's proceed to row 4 and row 5. Where did this come from? Okay? The row 4 came from your fixed end moment. So what we have solved earlier from this slide, all right? From this slide, we have identified the fixed end moments for each segments. Now, going back, how do we know where can we find now the carryover? So we will now proceed to the next step, meaning the carryover for the factors. All right. So you can simply balance. Okay, you should balance the following. So again, in order for you to summarize this one to be equal to 0, okay, that will give us negative 240 plus 0 divided by 2. Alright, that will give us 120 for each one. Alright, now how about this one? 240 plus negative 250, that will give us negative 10. But in order for you to zero it, you need to add 10, right? But you have to know the factors, what will be the partition or the proportion for the 10 kilonewton meter. That will give us, or that idea will come from the distribution factor 0.4 multiplied by 10, giving you 4. 0.6 multiplied by 6, giving you 6. Okay, 0.6 multiplied by 10, giving you 6. And then finally, you will have a distribution factor here of 250. Nasa table pa. Sa labas. Table nila Lebron. Okay. Now, we have here um, where can we get, or where did we get now the row 6 and row 7? So I hope you have already gets this, no? I hope you get this already. Now let's proceed to the row 6 and 7, where we will have again the distribution factor. So ito na yung division by 2. Okay? 120 divided by 2, we will get 60. And then in this one, 120 divided by 2, we will get 60. And 6 divided by 2, you will get 3. Okay? A question, where did this come from? The 250 here. This came from your, again, your fixed end moments. Alright? For CD. Or DC. FEMDC. Okay? Now, so, 120 divided by 2, 60. And then 4 divided by 2, that will give us 2. So in order for you to sum this, you can just simply add negative 2. And then divide that into 2, negative 1 and negative 1. Alright? And then this one, 60 minus 60 will give you 0. But why is this 24 and then negative 36? Because again of the multiplier. Okay? Now, again, carry over for row 8 and 9. Where did this came from? Negative 36 divided by 2, 18, negative 18. And then where did this came from? Negative 1 half divided by 2, 0.5. Negative 0.5. Negative 24 divided by 2, negative 12. Negative 1 divided by 2, negative 0.5. Alright? Now, next. Where did this row 9 came from? So, again, what should be added to negative 12 to become 0? That will be positive 12. Okay? But the distribution factor is 1 half, meaning you divide it by 2. So 6 and 6. And then how about this one? What should be added to 0.5 to be 0? Negative 0.5. You should add positive 0.5. But then, what will be the partition from the distribution factor 0.4 multiplied by 0.5, 0.2, and 0.6 multiplied by 0.5, 0.3. Alright? Now, again, for row 10 and 11, 6 divided by 2, 3. 6 divided by 3. 6 divided by 2, 3. 0.2 divided by 2, 0.1. 0.3 divided by 2. 0 is supposed to be 0.15, but it is already rounded up, so it's just okay now. We're getting very much close to the final answer. And then for row 11, again, 0.1 shall be subtracted by 0.1 in order for it to become 0. Okay? And then divide 0.1 by 2, negative 0.1 by 2, you will get negative 0.5, 0.05, and negative 0.05. Then how about this one? What shall be added to 3 to become 0? Of course, it should be negative 3. So negative 3, what will be the partition for row 11? That will be negative 3 multiplied by 0.6, giving you negative 1.8. And then negative 3 multiplied by 0.4 will give you negative 1.2. And then, for row carry over again, that will be negative 0.05 divided by 2 will give you negative 0.025 supposedly, but it is already very conservative na, maliit na, no? So it's okay to just write this one. And then just carry over again, 0.05 divided by 2, negative 0.02. Negative 1.2 divided by 2, negative 0.6. Negative 1.8 divided by 2, negative 0.09. So, for our final line, what shall be added to negative 0.02 for it to become 0? That will be 0.01 and then 0.01 and 0.3 and 0.3. So, as you can see here, you have already noticed that as long as it's getting smaller to the hundreds decimal place, we can finish our iteration or your solutions. Okay, then finally, so where did this come from? You just simply add the following, okay, per column, okay, from the steps already. So what is our step again? This one, right? Summarize the columns. So you sum everything. AB 0 plus 60 minus 0.5 plus 3 minus 0.02 will give you 62.5. And for BA, sum, and sum, and sum, and sum. And then finally, the answer will give you the following. So moment of 62.5 kilonewton meter. By the way, no, the book approach is to be baliktad pala tayo. Okay? 62.5 clockwise. And then for clockwise direction, that will give you positive. Uh, for counterclockwise will give you negative. Alright? So that will give us an idea of bakit ganito yung ano natin. This one. Alright? So the fixed moment for BC. Okay? You have distributed load. So for BC, kabaliktaran. Alright? In this case. Omega L squared. So, counterclockwise pala. Kaya negative. Okay? So, we just notice it. Oh, sorry about that, yes. But, nonetheless, this is our uh, uh, final solution. Alright? So, I hope you get this lesson for the moment distribution method. And that will be it. Comment down in this video if you will have any question or message me personally in my Facebook account. God bless you all, guys, and thank you. Isang bagsak in 3, 2, 1. Boom. Bye-bye.